This is a textbook exercise that involves error in approximation. We see f of x is e to the 3x, and then suppose the absolute value of x is less than or equal to 0.1. We want to find a reasonable upper bound in the error when we approximate this function by the third order Maclaurin polynomial. This is what we see here. Well, before I get started, here, this part is telling me my interval. It's saying that we use the interval closed minus 0.1 to 0.1. We are within 0.1 of 0. And then what is the error? This would be E3 fx 0. This is Taylor-Lagrange. We know what it looks like. It looks like the very next term in the Maclaurin polynomial, which would be the fourth derivative at some c over 4 factorial times x to the fourth power in absolute value. So this is what the remainder looks like. And then to get the error, we put absolute values. And this is for some c in this interval. And we don't know what C is, and our goal is not to find C. We want to find an upper bound on error using this, okay? Well, here I have this chart, so we can start calculating derivatives to get ourselves to the fourth derivative. My function is e to the 3x. I differentiate. This is chain rule. Differentiate again. Differentiate again. Oh, maybe I'll start writing it as a power. This would be a 3 cubed, e to the 3x. And then we have a 3 to the 4th, e to the 3x. So this is my fourth derivative that I will use. 3 to the 4th times e to the 3x. Okay, maybe I'll put this here. This is equal to, well, this is positive, so I will just put 3 to the 4th, e to the 3x. Oh, c, excuse me, and then divided by 4 factorial, and then we have absolute value of x to the 4th, but x to the 4th is always non-negative, so I could just write this. Okay, now, if you remember, which we have discussed, this is a two-step process. First, I want to see how big can this be, or I could just look at the fourth derivative, but this part, how big can this be on this interval? And second, as a separate question, how big can this be on the interval? So first of all, we look here, this function e to the 3c or e to the 3x, this is increasing, right? This is increasing. And so the biggest it can be for an increasing function is, I'll say, is at the right endpoint. So I can say this is less than or equal to 3 to the 4th over 4 factorial, e to the 3 times 0.1, which is 0.3, and then x to the 4th power. And then second, we want to say how big can this be on the interval. So first we looked at this, and now how big can x to the 4th be? Well, the biggest it can be on the interval, really it's at either endpoint. And so let's just use, doesn't matter, the right one also for this. This would be less than or equal to 3 to the 4th over 4 factorial e to the 0.3 times 0.1 to the 4th. Now, this is an upper bound, and we could put that in our calculators. The problem is, this is not the best way to leave our answer, because if I say, approximate e to something, how close are you? And you say, well, I am e to something. Well, how close is that, right? So leaving this in an error estimate is kind of circular. If you're trying to approximate e to something and you have this in your error bound, it's a little bit circular. So a better answer would be to have one more less than or equal, where I have some number that I can confidently say is bigger than or e to the 0.3. So let's talk about that over here. Make a little side box. E to the x is an increasing function. And so this is definitely less than e to the 1/3. And now I can confidently say this is less than 2. And why is that? Well, because e is less than 2 cubed. This is 8. And this is a number between 2 and 3. And that we can prove using series, for example. But e is between 2 and 3, and it's without a doubt less than 8. And so that gives us this. We have this here that we can use. So the final step here would just be less than or equal to, we'd have 3 to the 4th over 4 factorial. And then I can put a 2 here, and no longer do I have this circular reasoning in my upper bound for error. And then this here is approximately, there's 3 zeros, and then 6, 7, 5, okay? So this is technically a better upper bound because I don't use e in my answer, okay? So this is this problem from our textbook, and thank you.